What's up, guys? Welcome to another... I'm going to use... No.
Spectacular's good.
No,
it's
I don't
going to
like
be
it.
spectacular.
Sublime.
Actually, Sublime's pretty
Sublime.
fitting. Yeah.
Yeah, because now you'll see why that's related.
Yeah, but that doesn't mean
topic.
It's also going to be spectacular, obviously.
Yeah.
As well.
Yeah.
But that's just not this week's.
Anyway, welcome to another Sublime episode of Off-World, Off-Topic with me, Sam Paler, and Mark Fox-Vale.
Hey.
Off-World, Off-Topic is Off-World Empire's weekly show, although we weren't around last week.
Yeah, just a cheeky week off. So welcome back after that short break.
The short hiatus, necessary hiatus.
Yes.
So, plans today.
So yeah,
related to sublimation.
Yeah, so we've been kind of hinting about this for quite a long time, but we're actually going to be diving into artificial intelligence this week.
Yes. It's probably going to be
a long time coming.
We're probably going to do it as 2 episodes.
Yeah, I mean at least
2 episodes. It may break up into more.
Yeah, probably. Let's say 2 for now.
Yeah.
Just in case we don't want to oversell ourselves. It's going to be 2 episodes.
Yeah.
Maybe more.
Maybe more.
So today we're going to be focusing on the emergence of AI and
all its potential kind of consequences.
Yeah.
Well, not consequences so much today, but more like how it might emerge.
Yeah.
And like when it might
things
emerge
leading up to it and that
what's happening today that's related to it. Maybe.
Exactly. Yeah.
So it should be good. AI is like super interesting.
Yeah. I mean, it's sort of it's maybe
it's potentially the
topic?
King of topics.
It is. Yeah. Everything sort of ends up coming back to it.
Yeah.
That we talk about. It's like, oh, well, what about AI? It ends up.
Yeah, it does.
Like, what about you think of this in the context of AI?
And potentially everything else gets washed under the rug.
Yes.
Like if certain things about it are true.
Yeah.
Anyway, before we go into that, I did have some thoughts about some of the stuff we were saying about consciousness last week.
Yeah.
That I thought would be good to discuss a little further. So we said last time about how you couldn't predict the thoughts of someone or their actions in the future because of chaos.
Yeah.
Because you can never know the starting conditions really accurately.
Yeah, because I think basically things are infinitely divisible.
Yeah.
You never know starting conditions accurately enough to be able to predict all the kind of.
And then I thought, I have heard of the Planck length, which is apparently the smallest the smallest you can divide. Is it space time? It's the smallest relevant length.
Yeah, it's
of
whatever that means. It's basically the smallest divisible unit of space time that's predicted by various mathematical models.
Okay.
And it's real small for a start. Very, very small. It's something like 1.6 times 10 to the minus 35 meters. It's length. It's like a length scale.
That is small.
It's really small. And actually, there's an analogy. It's on the Wikipedia page, so it's easy to find. It's quite a simple analogy to kind of visualize the size of the Planck length.
Yes.
Like how small you have to get down to be able to measure the length of the Planck length. So if you imagine a dot that's 0.1 of a millimeter in diameter. So a millimeter is pretty small anyway. So a 0.1 of a millimeter is like a tiny dot you might do with a sharp pencil or something like that. Like really, really fine pinprick.
Yes.
Imagine that scaled up to the size of the observable universe.
Okay.
Right?
Done.
On that scale, the Planck length would be the size of a 0.1 millimeter dot.
Oh shit! That's so cool.
Yeah. So that's how ridiculously small this thing is.
Yes.
So if that tiny pinprick 0.1 millimeter dot was the size of the observable unit, so the Planck length would be the size of a 0.1 millimeter dot.
That's mental.
It's real small.
Yeah, so it's really small. So apparently that
but theoretically it does exist. It's a length scale that does exist. So when we were saying that things are infinitely divisible, perhaps they're not infinitely divisible, and you could actually, if you had a big enough computer to compute all these decimal places of a meter or whatever, you get down to your
Planck,
your absolute number.
Yeah. Is that so? The problem is though that exists in the quantum realm, doesn't it? The Planck length.
Yes.
At that scale, quantum effects are the dominant force.
Absolutely. Yeah.
Gravity and relativity, everything's kind of died off.
Yeah.
So in quantum effects, it might be deterministic, but it probably at the moment seems like it's not a deterministic system. As in, you can put in exactly the same inputs, and you might X percent of the time you get a different output to another time.
Yeah.
So essentially, it is maybe not a deterministic system. There is some theories about hidden information that maybe actually is deterministic, but there's some kind of hidden information transfer that means that the starting conditions aren't the same, even though you put them in as the same.
But that's the whole thing in quantum mechanics. Like, I mean,
it's a probability.
Everything's a probability distribution. So, if you had a computer that was capable of knowing like the positions of all your like atoms or whatever, or subatomic particles, whatever the hell you're talking about, to the point of a Planck length, like that kind of level of accuracy, you still have these like probability distributions that still mean you have like probably an infinite number of possibilities. But because it's a probability distribution, you'd be able to choose the kind of average, like the 95% of the time is going to be within this like this part of the bell curve.
Yes.
Or something like that.
Yes.
But you're still never going to have know it exactly accurately enough. No. And that's the problem, is that with something as crazily complicated as consciousness, like a conscious mind,
mad
complex. Like all of these things are going to diverge so rapidly. Like even these tiny little errors you make at the scale of a Planck length in your calculations, like the fact that you're on a probability curve, like the next step of the mechanism, or whatever, you're going to introduce like another level of uncertainty.
But like that, exactly. But there's not only that problem as well. There's some kind of like macroscopic behaviors that might be unsolvable from knowing everything about the microscopic behavior or something. So like the example that's been out recently was about how you potentially can't predict like a superconducting type behavior in a material from knowing all of its like its like microscopic conditions, because you get like unsolvable equations. Basically, it means that you can't follow the line through, even though the line exists to the superconducting behavior.
That's mad.
You simply can't know between the two.
Some
mathematical reason.
Sorry,
it means it's like unsolvable, an unsolvable like undivisible equation at that like superconducting behavior. They don't line up. I don't fully understand why that happens, but apparently that's been suspected to happen in some like macroscopic behaviors. So potentially something like consciousness has like components that couldn't be predicted from its microscopic behaviors anyway. Yeah. As in same thing happens in superconductors.
Yeah.
Maybe.
So you need to know like multiple levels of the cause effect, like whatever structure, all of which like depend on each other. Yeah. So it's kind of impossible to know all of those things because they're interdependent.
Yeah. Something like that. There's some reason. Basically, the math says that there was some paper out, I think, by some group in Madrid or something, that said that they basically like proved that, or they claim to have proven that it was there was an unsolvable component to predicting superconducting behavior in certain materials. So maybe there's some sort of scaling up thing there that would also mean that you wouldn't be able to predict the thoughts of someone. As well as this, given
like absolute knowledge like on
of
a
the
Planck
microscopic
scale,
level,
of like what's going on in their brain or whatever.
Yeah. You wouldn't be able to do it from like a ground up kind of style.
No.
Which is interesting.
It is interesting
because that has loads of implications. If that's true for like lots of different behaviors, like ground up studies of certain things may never be able to meet quite in the middle with kind of top down studies.
Yeah.
But I mean, it may only apply to like certain very specific examples, like
I'd like to know a bit more about that. Really, like why the thoughts are of why those kind of that disconnect exists. Because that's really unintuitive. That's hard to like get your head round.
Doesn't make sense.
Like why it should be like that.
But apparently they've been suspected to exist in physics for a while.
I mean, I understand that it's functionally impossible to predict macroscopic behavior, but like the idea that it's fundamentally impossible for reasons apart from just like
it's not that
rounding errors or whatever. There's actually another like fundamental reason. Like that's mad.
And it's intrinsically like impossible to link the two. Maybe. That's what the groups claim to have.
Sure.
And I'm pretty sure that it was in the news and stuff. I don't know what the general like consensual reaction in physics has been, or whether it's had like time long enough for people to properly analyse what they've done. But apparently it's a thing that's been suspected for a while. Yeah.
Mad.
So again,
I still think,
same conclusion. I think
so. I think we're still safe from like mind reading, future predicting props machines.
Yeah. No Minority Report. Style crime convictions.
Yeah.
They might be able to do like a prediction of a probability though. Like this person's got like an 80% chance. But then we don't allow lie detectors to be used in court and stuff because they're not particularly like there's a percentage like chance that they give false readings.
Yeah. But presumably maybe that kind of stuff is going to become so good that we will decide to use it.
Yeah, I
in
mean,
future.
all I mean is that like making the prediction on a percentage basis that someone might kill someone is never going to be enough to convict them.
Under
any like government system.
because
You might
you're always
say,
like certain percentage of the time you're going to be convicting innocent people.
Could you lock them up for like a week so they're not going to be like the chance of it goes down for a while? I mean, you're infringing on their human rights.
That's dodgy territory there. Yeah, I don't
definitely
know.
is.
Yeah, I mean that almost is like Minority Report, isn't it?
It is. But you don't have to lock them up or charge them with the murder. You just say like you've got a high chance of killing someone this week, just at this time you have to go and like live in like a little hotel or something.
Yeah. And then like the whole time you'd be calculating the new possibilities. You'd be like, oh shit! Now we've locked them in the hotel. That's actually like double their chances of. We've lowered the chances of them killing this person. We've now tripled the chances of them going out on a rampage like down here.
Hold on, shit. But if you've predicted that they're going to kill someone in the future, with this like thingy, and then intervened. Then you've just changed this. The future was never that in the anyway. The future was never going to be. Yeah, going to do that anyway.
Oh yeah.
Anyway, let's not go down the time travel kind of like route. This is a whole mess waiting for us.
Yeah.
Right. Let's move on.
Let's do it. Let's
get right on artificial intelligence.
Jump in.
So, what is artificial intelligence, Mark?
Artificial intelligence. Yeah. What is it? I guess it's kind of a fairly simple concept, like conceptual thing. So intelligence just being like the processing of information, almost like on a very basic level.
Yeah. What was it? We defined it last time, didn't we? Intelligence. It was like when we were talking about civilization.
Yeah, like acquiring and applying knowledge.
Yeah.
I think was
to
what
achieve
it was.
like tasks and goals or something like that. What it was. Yeah.
So it's just that it's that behavior exhibited by machines or software, basically. So
yes,
like
exactly.
acquiring and implying information.
The ability to acquire and apply knowledge and skills is the definition.
So knowledge in this sense is essentially just information. If you're talking about various things that could be classed as artificial intelligence that already exist, we might not say that they have knowledge in the sense that we have knowledge.
Yes.
But we'll get onto that in a minute. But anyway, so in the very basic definition of the word intelligence, artificial intelligence is just purely that behavior exhibited by machines or software.
Yes, exactly.
So given that it's that kind of seemingly quite simple thing, so like why is it such an important thing? Why do people
so you probably have noticed over the last it's only really been kicking off, I suppose, in the last like 2 or 3 years that like obviously people have been researching for forever,
for decades,
but you started seeing it a lot more in the news fairly recently, that kind of these figureheads, people like Elon Musk, Stephen Hawking, all types of people talking about the dangers of AI or that AI is a big deal, and that actually a lot of like you'll have heard of various companies that are trying to build AIs or do AI research, and the AI is becoming this kind of like suddenly we've been interested in it for a while, but suddenly it seems to be becoming more of like a concern to the general population.
It is.
Seems
people
to be more
are talking
in the
about
news.
it more. Yeah. You see it popping up more. People ask you questions about it more, and it's generally just in like the collective like consciousness more now. Yeah. So
definitely.
Yeah. So what?
Why is that?
Why is that? Yeah.
Well, potentially because it's like we need to sort of make a bold claim and then back it up. But the backing up's going to happen over like a few episodes. Yeah. It's potentially the most important thing that's ever happened to humanity.
Yeah.
And possibly the most important thing that has ever happened on Earth.
Yes. The most like significant fundamental change that has ever happened and possibly will ever happen on Earth and to life, that as far as we know it, the only life that exists. So like based on our current understanding of the universe, it could almost be like the most significant thing that has ever happened in the entire universe, possibly.
Maybe that's a big claim.
That's a big claim.
But and there are some arguments that maybe this is why. We'll go through like why it might be important or why it might not be. But there is definitely a kind of a group of people, a large group, an ever-growing group of very intelligent people who are starting to think that it's like it's so important. Like everything you've ever done, everything your family's ever done, everything your species that life has ever done boils down to getting this right. And if we get it wrong, then all of that just evaporates.
Yeah.
Potentially. Yeah. And if we get it right, then it could be pretty
awesome. It could be pretty great, yeah. So it's a weirdly, unlike most other things throughout the development of humanity, it's a weirdly binary outcome. It seems to be, and we'll come back to this as we go through.
There are some kind of like midway points and things, but the end point of it is potentially like a hugely beneficial or hugely awful thing.
Yes.
For everything on Earth.
Yeah. And we're talking.
That's how cool it is.
Yes, yes. And obviously, I said just a bit earlier that like artificial intelligence to a certain degree already exists. So when we say that it's the most significant, or potentially the most significant, most important thing, a particular type of artificial intelligence, and that would basically mean artificial intelligence that's more intelligent than humans. And as we said, we'll go back and like back up that claim. But like on the face of it, like the main reason, kind of underlying reasons why that could be such a hugely important, hugely significant things, because if that happens, we essentially hand over the dominance of the planet, all the decision making that's ever going to happen to the future of the planet and the way it's used and the resources and our own future will now be done by
will not be decided by us.
Not be decided by us. No.
It's like you think back to this sort of industrial revolution. Like most of the sort of mechanical heavy lifting is no longer done by humans. Yeah. Because we had a revolution in machinery. So like all manufacturing, everything's done by, these machines. Yeah. Well, imagine that, but that all the intellectual heavy lifting is done by machines. So that we don't do any of the intellectual, we don't do any of the science, we don't do anything basically. We may have no role whatsoever. Yeah. We just like pleasure bots. We just do whatever the fuck we want, or we're dead, or whatever. Yeah. There's lots of outcomes. Yeah. So that's the significance. You're handing over the planet to something potentially that is much smarter than we are, and we essentially become secondary to it. Yes. In terms of its capabilities.
And in the same way that we were talking about in previous episodes that there were obviously very intelligent animals around before we sort of emerged that were doing very well. Yeah. And had a mastery of their environment to a certain extent. As soon as we were around, we were more intelligent than them. They are basically just animals in zoos now, in a way. Like we have dominion over them. We can do what we want, essentially. Absolutely. The same step change would apply here. Yeah. The thing that has led us to become so dominant on the planet is our intelligence, as we've talked about. Yeah. And that's essentially the equivalent thing that would be happening here. So you'd be having a machine that's more intelligent than us, would be more capable than we are. We would basically end up like animals to it potentially.
Yeah, the gap might not be. Yeah, the gap might not be animals. It might be like us compared to rocks or something like that. So it gets pretty mad. It gets
pretty insane.
But
like functionally, that's kind of like the what makes it so important, what makes it so significant and important to talk about,
and so interesting. Yeah, it's like I read this sort of stuff and kind of think about it, and there's few things that are more interesting.
I was saying this the other day, like when I think about this kind of stuff, I get a feeling that almost nothing else gives me. And it's not just the kind of technical aspects of like artificial intelligence. No, it's what it means for the future. Yes. What it potentially means for the future. And yeah, we'll get onto that.
Yeah. So yeah,
I'll try and hold it together.
So this transition from us doing the intellectual heavy lifting to computers doing it, or machines doing it, you would have probably heard referred to sometimes as the singularity. Yeah. Or you've heard that like word banded around.
The technological singularity.
Yeah. Which is a cool word.
It is a cool word.
Cool phrase.
That word pops up a few times like throughout like the sciences.
It's
the cool word.
It
singularity.
Is a cool word. But the basic concept behind the technological singularity is that it's a point in our technological development in which events become unpredictable, potentially unfathomable to humans as we now understand the world, as we now know humans. Yeah. So in the same way that like a singularity in a black hole has like an event horizon you can't see past, it's kind of a similar kind of analogy to that. You get to a technological singularity and you can't see, you don't have no idea of predicting what happens after it, because whatever happens after it is so much more, it's so different, it's so much more advanced. Like orders of magnitude potentially more advanced. Yeah.
So it's a point beyond which it's impossible to predict or even really imagine what the future holds beyond that point.
You'll have heard other various definitions of like what constitutes a technological singularity. You might have heard people say like the merge of brains and computers, like human consciousness and computers.
Yeah, which seems a bit muddy. Seems a bit like
that's not really. I don't think that's like the proper definition. But I've definitely heard people say the technological singularity is a point where brains and machines will merge.
I mean, that is something that's very difficult to imagine what it would be like after. Yeah. But the thing is, it's only one possible outcome of the technological singularity.
Exactly. Yeah. That might be like a feature of the technological singularity.
Yes. But the kind of like, it's usually tied to this thing of recursive self-improvement.
Yeah. So the ability, the technological singularity is directly related to AI. Yeah. Really. I mean, well, yes, it is related to AI. Yeah. Absolutely directly related to AI.
It's where you get to a point where technology, specifically intelligent systems like software and stuff, is capable of actually learning about its environment, but not just self-learning, but actually being able to go back and redesign itself to be better at learning.
Exactly. Yeah. So it can either recode itself to make its software like smarter, more intelligent, and therefore it gets better at doing that process and going back and making it better. So you get an exponential increase in intelligence. Yeah. Or it does the thing where it basically is able to somehow interact with the physical environment and can build like machines as part of itself that make it like give it more processing power, and the machines get better and better and better. So it's one of those two or both of them probably. Yeah.
So you end up the fact that it's capable of going back and being like, okay, like I've learned this stuff and this is how I make myself better at learning the next stuff or whatever. Like you get that it turns into a feedback that turns into a runaway intelligence explosion, and that's why it's so difficult or impossible to predict what will happen, because we don't know how quickly that will happen. The acceleration of that could be absolutely like mental fast.
Yes.
So it's this idea that there's this point coming at which that as soon as that initiation happens of something that's capable of doing that we end up going through this intelligence explosion.
Yes.
That's the concept. That's the kind of concept of the technological singularity.
And we say it's coming. I mean, the predictions that there's a bunch of different like sort of dates that people suggest the technological singularity could happen. But they all exist this century.
Yeah.
Which is nuts. Which is scary.
Yeah.
And awesome.
Yeah, it's both scary and awesome.
Yeah, because the potential outcomes are both scary or awesome.
Yeah.
So the mean date amongst, I think, like high-end AI experts in their field is 2050, isn't it?
I think so, yeah.
And 2040 for a more general kind of poll.
Yeah. So, I mean, a lot of people will obviously have read the Timmerman's Wait But Why post on AI.
And if you haven't, go read it, because it's friggin'
really,
awesome.
Really good. It's a very, very good, like, it's a very introduction. I mean, it's very, very detailed, well-written,
it's one of the best
in-depth introductions.
It's one of the best kind of popular science articles I've ever read.
Yeah, for sure. It's really, really good. And in that, he goes into a lot of detail about these kind of predictions for when the singularity might happen. And like when I read that, I had no idea that they were so like soon. I knew that there were some people predicting that it was soon, but I didn't realize that was the consensus like prediction.
Yes.
That it was going to be not just this century, but like within a few decades of now.
Yeah.
Like not like 2092 or something, but like 2050 is the mean date for this.
Think about that. We'll live to that.
Yeah.
Unless we die early from something.
Yeah.
I mean, that might happen.
Yeah, sure, it might happen.
Yeah, don't care.
Building might fall down in like a minute or something. I don't know.
Oh Christ!
Yeah, it's a pretty old building.
There's no earthquakes here. Those were good.
Yeah, but don't you feel the ground shaking every time a truck drives past?
Yeah, that's true. Actually,
yeah, it's a bit dodge. But anyway, so as long as that doesn't happen, and like a million other things don't happen.
Yeah. Okay. So presuming we live to like an average kind of old age,
it will be within our lifetimes. This mean
this predicted date. Yeah. I mean, obviously it might not happen.
You have to go back. You have to take that with a slight pinch of salt in the fact that people are predicting this since like the 50s and stuff, like the 60s, when like Turing machines, like computers were starting to be built. People were like, oh yeah, we're gonna have like human level intelligence in machines within like 20 years back then. And these things always get pushed back, and predictions. Like people fusion. Realize it's much harder than it actually.
Like nuclear fusion, it's always 30 years away.
Yeah, but maybe there are good reasons to be sort of thinking that it is close now, or closer. Yeah. A lot of things seem to be moving in a sort of common direction. And there's a lot of stuff. There's a lot of acceleration in the areas.
I mean, there's a theory that human development is exponential anyway. that it basically gets easier and easier to get better and better technology. Now, that people say it happens in like a step fashion. So you get like a sudden like revolutionary piece of technology that increases it really quickly. That matures, takes some time, and then you get another breakthrough and it increases very quickly. But some people argue that there isn't an exponential increase in human technology, just in like certain types of human technology. Like, for example, we've had Moore's law running for a good while now on like computing power. But
it's actually going through like a deceleration at the moment.
It is, yeah. Exactly. So
that's possibly going to plateau.
Yes. And so people like Ray Kurvitz, or whatever his name is, say that Moore's law is just at the current time, or was at the current time, like one of the proxy measurements for this exponential curve.
Yeah, sure.
And that something else will then begin like exponentially increasing as the computers tail off in another way or something like that.
So when you actually take a step back... So
you go back to like cathode rays and all these other technologies before, you still see exponential increases, but they all tail off and get superseded by something else.
So when you kind of scale back and consider like human technological advancement as a whole, not just like right information technology or like transport or anything like that, but just like everything... then all these step changes and plateaus average out to something like an accelerating increase. That, at least that's the argument that people like Ray Kurvitz or Kurzweil or whatever put forward.
Yes.
Which is, I can see that. You can see these overlapping trends of exponential growth in technologies.
You can, but yes, you can.
And they trigger each other and stuff as well, like,
Yeah, absolutely. I mean, what computers have helped us with everything, understanding everything.
Exactly.
Yeah. I mean, there's loads of other proxy measurements for like DNA, increasing like sequencing technology, saying that sequencing technology gets, I think it like halves in cost and gets twice as accurate, or does twice as much throughput every X number of years or something. And they will follow these cyclical kind of.
And it might be that to get to the technological singularity, you need like not just advances in like an exponential growth of IT, of information technology, but also like materials science and stuff like this to build the kind of hardware that you need, possibly. We'll reach like processing limits of like what silicon can do and stuff like that.
Yes, you need to build new types of computers that run on different things. Other innovations that aren't just like how much transistors you can cram onto a piece of silicon will take hold as more important. Or necessary because we can't keep cramming these things on because they get to a certain size and are useless. I can't remember the exact definition of Moore's law.
Is it doubling?
Is it doubling the number of transitions on like a dot?
It's something like that every 2 years.
Yeah, I can't remember exactly.
Yeah, I can't remember exactly either.
But it gets problematic because as everything gets smaller, the atoms basically can't move through these gates and stuff. You get to the point where you're like working with things that are the size of the
atom size almost, exactly. And then you're done. You can't go any smaller than that.
And it becomes harder and harder. So you'll see these advancements in like the size, like the nanometer technology. So how big manufacturing is. So I think like Intel's on like, can't remember, 12 nanometers or something like that. But it's taken there's 40 nanometers maybe.
I mean that's tiny.
I can't remember exactly where they are now.
Ridiculously
but those jumps in size on those dice were much faster a few years back, 10 or 20 years back. Every jump was coming much quicker, and now they're starting to be harder and harder to reach.
Which means that particular proxy for human growth is
plateaus out.
But that doesn't necessarily mean that human technological growth is plateauing.
No.
But it almost certainly doesn't mean that.
No. So the singularity and this kind of explosion of human development is like a debated thing. It's not like a dead set kind of. Not everyone is consensually agreeing on this. But it does seem like human technology does go through these kind of explosions. These kind of I mean, Tim Urban in his article pointed out that it was like between 1984 and 2000 there was like a much smaller change than there was from 2000 to now or something like that. And I can I think I agree with that. It depends. So. But the other thing is that like you get certain technologies that affect you are like what are normal daily lives more than other technological breakthroughs. So for example, in the last few years we had a huge breakthrough in internet. In the last like 10-20 years we had a massive breakthrough in the internet, smartphones, the miniaturization of process, all these types of things, and that had like a massive impact in how we consume it and you know,
like
consume media, communicate everything. Whereas in the last, since that, I suppose that hasn't changed that much from like 2010 till now, in the sense that it's matured and you know, like Facebook and you know, everyone's, it's just like a thing that's like in the background now, and everyone has a smartphone, but everyone has a smartphone in 2010. So it's kind of like that's it plateauing. You can feel it plateauing, but then there will be like another jump in kind of how we interact with technology or types of technology that will happen. Probably, you know, I mean, VR may be one of the one is like a thing that people are talking about. And
could be the next.
That will be the next thing that you'll notice as a kind of like, you know, layperson, as a person who's just in the not working in like a specific field. These waves of exponential increases in and big changes in our daily lives governed by technology happen in like bursts, but they don't happen like every 5 years. And so, like, for example, in the last 5 years, although smartphones have been the same, they've been, I mean, like, they get faster.
I know what you mean, but they're performing the same like jobs.
They're not that different in terms of our experience of using them. But like there's been
shinier,
a huge change in like sequencing technology in that time.
Which DNA sequencing technology.
Which you don't hear about if you're not in like those areas doing that research. So
like orders of magnitude, it is just insane how the advances that have been made in the last 10 years in that.
In the last like 3 years.
You're right.
So that sometimes it seems like technology slows down and goes again, but like there's loads of different like you know, huge increases in technology and jumps happening all over the place. That are not so noticeable. And I don't know. It just seems like there's more kind of things happening, more advancements. Everything's moving in like a kind of faster and faster direction. It seems to me, just like qualitatively. I don't really know.
Qualitative, but that doesn't necessarily, on the face of it, I agree with all of that. But that doesn't necessarily mean that we can predict from that the singularity is at 2050.
No, but what it does mean though is that you if there is an exponential increase happening, is that like things that seem very far away, very far in the future, are going to come at us faster and faster and faster. So they seem like they're like a million miles away until they're basically get to like
tomorrow.
Until they're tomorrow. Exactly.
And that's probably what's going to happen with this.
That's the prediction with the singularity, is that you have that like we're almost like in a runaway kind of intelligence, kind of like technological advancement. And the technological singularity seems like a totally like nebulous idea. And then 5 years from it happening, it's like, holy shit, like the whole of like society's being run by like AIs and everything's kind of, and then like
how is this happening? Like how the hell has this happened? This is crazy. Like 5 years ago we were all just sitting around talking about this happening in 100 years, and now it's here. You can imagine like a graph. I mean, it's not very good talking about this kind of stuff without it being a visual aid, but like a graph of like human progress, like arbitrarily on one side.
So there's one in that weight but wire.
So human progress up the vertical axis, and then like time along, and like the jump between now and AI is like massive on the progress bar. But because of this exponential curve or this accelerating curve, like the time that it takes to get from now to that point is like much shorter than you might think based on how much of an advance it actually is. Anyway, so the thing is that we're starting to see now in the world loads of pretty advanced, or like seemingly very, very advanced intelligent systems that are just sort of becoming part of our lives.
It's worth probably distinguishing now between the different types of AI.
Definitely.
So when we're talking about like this explosion of different of intelligence, this is like intelligent explosion, a recursively improving artificial intelligence, that's like an ASI. So that's an artificial super intelligence.
Something that becomes an ASI. So super intelligence is basically just something that's vastly more intelligent than us.
And below that you have, I'm going kind of in the weird order here, but below that you have AGI, which is an artificial general intelligence, which is basically like an artificial intelligence that is equivalent to a human. In terms of its like intelligence, if you take the definition of intelligence as its ability to complete like tasks and
the ability to again acquire knowledge and skills, or apply knowledge and skills. So general intelligence, it can perform tasks to the same ability is us in
Yeah.
the sense that and not just like, like making a cake or like working out some sums or something, but
Yes.
like abstract reasoning and
exactly,
and like imagining itself in different
It
situations.
could develop its own like hypotheses for things.
Planning for the future.
Plan for the future.
Make internal decisions that are intrinsically affecting, like we were talking about last week, like conscious decisions.
So it's like
kind of
if you take in like the integrated information thing, it's like phi level is like roughly equivalent to ours.
Yeah.
If
basically.
you watch the consciousness episode if you want to learn more about that.
Sure.
Because I think we knew what we were talking
yeah,
about.
so you want to learn more about that, maybe go read about it if you want to learn more. If you want to hear us talking about it, watch the last episode.
Yeah, it's a better way of putting it. So something that's roughly equivalent to us.
So some people think that the emergence of AGI, so artificial general intelligence, is the singularity, basically. So like at that point of suddenly now having a technology, an artificial intelligence, which is the same level as humans, that is one and the same thing as a recursive self-learning, like intelligence explosion, and that moment will then kickstart that whole runaway.
Yeah,
like
I suppose like humans are capable of going and modifying like algorithms and things, and like so if an AGI could do that, then it would be able to, because unlike a human where it can't go and like modify its brain. But maybe, it might be that once you get to like that level of intelligence, it is able to, like a human level equivalent is able of an artificial intelligence, which is obviously very different to a human anyway. Yeah. Is able to go back and like restructure parts of it.
Well, that's the thing. The human brain has obviously emerged through
totally different
process, but it through evolution. So it has been in a way like a kind of like a recursive self-improvement in a sense, that's a bit of a stretched analogy maybe, but so I think some people certainly suggest that you might be able to get very close to human level general intelligence by just designing it, like, right, this is how it's designed. But then you actually need an element of recursive self-improvement to actually make those final steps, and once you've done that, then of course you've ended up with your runaway.
So you might even get like sort of close to an AGI, and you get like as close as you can, you give it this like, imbue it with this ability to like do this recursive self-improvement, and you never really get to AGI, you just go flying past it.
See you later. Which is possible. I mean, I don't know, like it seems to me to be equally possible that you could design a machine that had general intelligence that wasn't capable of recursive self-improvement, just because of the fact that we exist. So if you're aiming for that kind of level of intelligence, we are not, as you said, we're not capable of like going in and rewiring but we might be able to one day
rewire our own brains. The thing is though, with an AI, it like might not necessarily like kill itself to do that. Whereas like we kind of might kill ourselves. It might be able to like separate parts of its kind of structural code out. Although if it's like a highly integrated information kind of system, you might find that it's much more difficult to do that, and if it like pulls any parts of its own thing out, it stops working. It
no longer has that phi level, that integrated level, so it ceases to be.
But it might
AGI.
be so it might have to be smarter than I don't know actually.
It's definitely tricky, but anyway, so there's definitely like a school of people who think that is the singularity. But it's interesting, and it's also worth saying that an AGI, even though it's referred to as like human level intelligence, doesn't necessarily mean that it's like just like a human in a box.
Absolutely not.
It could be completely different to a human.
Exactly.
Like the way that it functions on every level could be entirely different from the way that we function.
So exactly. So it's like its ability to like acquire knowledge and use tools and stuff, as in it's the definition of intelligence is that it's the same level as a human at doing those things. But like it hasn't gone through millions of years of Darwinian sort of evolution in a social group, which means it's basically like an entirely different entity. It's just as capable as a human.
Exactly.
It's probably not going to have the sort of human qualities you would expect in a human level intelligence thing.
It's quite easy to think of it as like a human in a box, because people talk about human level intelligence and things, and you think
and in films they're always like talking kind of they seem like quite human.
And I mean, to be honest, there is a branch of AI research which is doing, and we'll go on to this in a minute a bit more probably, but the whole brain emulation. So there is actually a branch of AI research which thinks that the most efficient way, the best way of getting to that point is by copying the human brain. In that case, maybe you would end up with something that's much more human in the way that it functions. So actually looking at the human brain
Yes.
and like using that as your like blueprint as how
Yeah.
to create an AGI.
If you've ever seen Transcendence, this is not a spoiler because happens at the start.
Sure.
I think they copy Johnny Depp's brain
Yeah.
and he becomes an AI.
Yeah.
So that.
So kind of that, but what I mean is a bit more, is not literally like sucking your brain.
Well, they
into a
like
computer.
scan him in.
They
Sort
do,
of,
yeah,
don't they?
yeah.
Like they put a load
Yeah.
of electrodes on his head and use that kind of like that kind of running conscious system to
spark off the
spark an AI,
whatever, yeah, the AI.
or just like I don't know, somehow recreating a computer. I know
Yeah.
it's a stupid film. Yeah, but they might do it like totally differently. It might be that you use that as a model to build it.
Yes.
And you spend years like slowly like.
Yeah, so that
parts.
neuron's there and that neuron's there and they
Yeah.
fire like that. Okay, let's code that in. You know, that kind of
Yeah.
thing. That's one like sort of way of attacking the problem. But then obviously there's loads of people who are looking at it from a totally different way. Like, okay, we have these like deep learning sort of algorithms and shit. Like let's build them up and let's
Yeah.
like make them more. And that's just not based on human brains really at all.
No.
I mean, there are maybe elements of it on like some level, but
Yes, yeah. Well, it's a bit like the old with a plane. We didn't try and exactly copy what birds were doing.
Yeah.
We just took some kind of like rudimentary elements from
Yeah.
what birds do and made something better.
yeah.
Because a plane, let's be honest, like a jumbo jet just dicks on a bird.
Yeah, I mean, if you want a better analogy for like what artificial intelligence might be in comparison to like our brains, then I can't think of one. That's pretty good.
Yeah.
Like
Yeah.
our brains are the birds, and then the AIs are the planes. Just gonna
Yeah.
just like suck us into their jet engines and liquefy us.
Well, in the same way that like a plane has nothing really in common with a bird except for the fact that they're airborne.
Yeah,
An AI may be as different from a human in terms of its type of intelligence, like what
Yeah.
it sort of perceives the world as and thinks about things.
yeah,
Maybe as different as a plane is, like the mode of flying in a plane and
Yeah.
and what a plane is.
yeah. Or a helicopter, which is even more
helicopter,
more,
yeah.
more different.
A
Yeah,
rocket,
yeah.
whatever.
Yeah. Anyway, so
So there's a third type, we
There's a
haven't
third
gone into, which is ANIs, which are artificial narrow intelligences,
Yeah.
which we kind of have everywhere.
yeah, I mean, this is the most basic of the three sort of classifications.
So it does a very specific. It's very good at doing a very specific process. But
Yes.
That's sort of all it can do.
And whilst the other two are things that will likely exist in the future, but don't exist yet, ANIs are, like as you said, they're everywhere. Like
Yeah.
they sort of, in some way or another, they kind of run the society that we live in.
Yes, I think that, well, like a really basic example would be like if you've ever played like checkers on a computer,
Yeah,
like against
Yeah.
or drafts or whatever you want to call it, against the computer. There's an AI like powering
yeah,
that draft game.
yeah. It just makes a decision. Like you make a move, and then it looks at all the possible.
It looks at some outcomes and then makes
a
another
decision,
move.
Makes a move.
And yeah,
Yeah, so
and you
that's
can
an ANI.
yeah, exactly.
It's doing that task and is doing it pretty efficiently, doing it very well. But it can only do that task. It's not going to be able to like, think
Yes.
about like some weird concept.
Yeah,
about
and you couldn't then like take that and ask it to like help run part of the economy. It just only does one thing.
Yeah, exactly.
Although some ANIs are they're able to do more like processes that are much broader, much more capable, but they're still not a general intelligence that can kind of like perceive things and like
Yeah, they can't like use what they've learned about this particular problem to apply it to a different problem in like a different context. They can't.
not to the same way humans can.
No.
So something more advanced would be something like Siri.
Yeah. The Siri's quite a good example. Like that's like in the Siri in the iPhones. Like
Yeah,
it seemingly, because it uses the internet. It's just a search engine essentially with a user interface.
yeah, but it's also got some very smart like are they artificial intelligence like language processing things?
Yeah, sure.
That sort of stuff,
There's definitely an artificial intelligence
Yeah.
aspect to them.
Yeah.
Like it's hearing inputs. It's recording. Well, it's listening to your voice and like calculating based on the sound of your voice. It'll choose the most likely sort of words that match to that,
Yeah.
and then like query them against a database.
And
So
it'll
all
also-
of this stuff is like
And it will
ANI
learn what you've previously searched.
Yeah,
kind
yeah.
of, it will start learning from your habits.
And that's the thing. You can have self-learning ANIs. In fact, they're everywhere.
Yeah, you can. Yeah, of course.
And like they're being designed like more and more advanced all the time. But the crucial thing is that they're not capable of recursively redesigning themselves and
No.
be better at learning.
Yes,
Which
is what you get if you. That's like the singularity.
That's the singularity. Yeah.
Yeah. So, but there are ANIs that are like. Well, I mean, there's some that really are kind of starting to look like things that we might expect that would go into something like an AGI or an ASI.
Yes.
just little hints of kind of like, oh, maybe things are moving in that direction a little bit.
Yeah.
So the stuff there's been actually, I'm gonna go so I'll start with an older example. So
Okay.
I think in like 2005, there was a model of the like neural. It doesn't really have a brain, but like the neurons basically of it's like a worm. It's like a polyp. It's not a polyp.
Super simple worm.
Yeah.
Like some kind of nematode worm. Or was it possibly even C. elegans, which is like that model?
Yes,
it's
it
like
was.
a model organism that's used like extensively in like biomedical research,
Yeah.
biotechnology, all that stuff.
So it's got like 302 neurons or something.
Which is mental.
And they
considering that the human brain has something like 100 billion.
Yeah. That's 300. Like, the fact that that's in hundreds.
And that is crazy, actually, just thinking about that. Like an animal that does what it does, like does all worm stuff, like swimming around and looking for food.
Well,
with
exactly.
302 neurons.
And so they built a model of it, and like a
Computer
digital model.
Digital model, yeah.
And the inputs and outputs they made are set the same as like the worm senses. And basically, you would put in the food kind of input, and the behavior of the system the output of it would be the same as the worm would be doing in its like rudimentary sense. So they're not telling it to do this, it just would behave in the way that like a worm would, but again, like in a very rudimentary sense. So it would like react in the same way the worm did to food. It would like do whatever the worm does, but it wouldn't be able to learn things. So it was like it was similar but very different in the same sense. Like the worm would be able to if there's like a higher temperature somewhere, it would be able to learn with just those 302 neurons that higher temperature equates to possibly like a more increased chance of getting food, whereas this like neural network thing doesn't have a clue, wouldn't be able to do that at all. Right. And it does that. It doesn't do that by adding neurons. It does that by like strengthening connections between certain neurons. And this system couldn't do that, but they could model some like extremely basic behaviors, not by predisposing it to doing
just by having that network.
By having the network in the same like structure. Same
structure and the various components of it. Having the same like or similar like thresholds of like firing or whatever that so like a signal comes in and it has to have a certain threshold to like then send off another signal, and these because it's only got 302 neurons, because it's so heavily studied, these aspects of it are quite well known, so they're able to actually put that into so this actually goes back quite nicely to that whole brain emulation stuff we were talking about just previously. So this is the same approach that some people want to take to designing an AGI, but instead of using a worm brain with 302 neurons to do it with the human brain,
increasingly advanced
with
brains,
100 billion,
and then 100 billion, and then potentially you take that 100 billion, and you've at that point very well like how you structure intelligence and maybe integrate information or whatever, and you could add things onto that to make it smarter than a human, and then it would probably end up doing its own thing. That might be a way to kind of like allow it to recursively self-improve or something. So that's like that's similar to the approach. The worm similar to that approach. Sure.
Yeah, but it's mental. Like thinking about that, like all you need is that network in place, and it just without any programming, it just does what the worm does on a very basic level.
Yeah.
Like.
You probably find that if they made that network so it could strengthen connections in certain places and do some of the more advanced stuff, it would essentially just behave as like a worm.
You've just made a worm.
And you sort of, is it a worm? I mean, we'll go into like is it a worm? It's kind of into the consciousness thing, but I mean, maybe you are essentially making a.
That's an entity. Rudimentarily, like it has a phi level, surely.
Yeah.
I mean, we are just in this discussion. We're just sort of accepting that integrated information is consciousness.
Yeah, we are.
That's fine.
No, but but even forgetting integrated information, I just mean if you're able to create a program that is behaving in exactly the same inputs and outputs, learns like more about a temperature or whatever as a worm. It's not a worm.
It's not a worm because to be a worm you have to be like
a worm,
an actual worm.
Yeah, there's no like biochemical inputs. No. But you could that's one way you could like model.
It might think it's a worm though.
Yeah, I don't know. There's probably more. There's more that goes into it than just the neurons, though. Yeah, of course.
Yeah, sure.
Yeah.
But, so that's one example of like is that an ANI? Yeah, sure.
I think so.
Yeah. Oh, well, it's possibly a step towards the direction of building some kind of AGI. But
so things that are going to contribute to an AGI are going to be like ANI steps that are kind of like not down the traditional kind of just play drafts route. It's going to be like a self-learning kind of like
Yeah.
self-evolving thing.
Yeah.
Sorry.
So sorry, of course. I mean, if an AGI, giving our early definition, is something that has human level intelligence, then like a worm isn't that.
But you're learning how to build these new like neural networks
Yeah.
that emulate organisms, and that's a step towards, maybe if you want to go down that route of trying to emulate a human brain, that's a step towards creating an AGI.
Yeah. There's some really impressive self-learning programs as well coming
Yeah.
out.
So you'll have seen in the news, like, you think about DeepMind.
DeepMind, yeah.
So Google DeepMind, they bought DeepMind it wasn't that long ago, actually, was it
No,
2 or
it
3 years ago?
Yeah.
And it's a
shitload of
London-based company, I think.
Yes, they are. Yeah.
And they essentially have been building algorithms, AI systems to play games. So things like
Like Space Invaders is one of the first
Space
ones.
Invaders.
But well, actually, they didn't build it to play Space Invaders.
That's the key thing.
Yeah.
But the idea behind this stuff is to like play games, but play them in a generalized, non-pre-taught way. So like they built an algorithm that could play like 10 different games.
Yeah.
But not from being told the rules of the games. Well, sorry, not from like being pre-told like these are all the different moves, etc., and programmed in how to do that. Rather, the AI would play the game again and again and again, knowing the winning conditions, and would learn how to play that game better and better from losing.
It wouldn't. Yeah,
it would just know
doesn't
the
even
positions.
play. Yeah, just knows the pixel positions. Just have a stream of data coming in.
Yeah.
Doesn't even know that it's playing a game.
No.
Just it had some kind of preset. I guess some preset winning conditions, as you said.
Yeah, I think so.
And it just like tries things like, oh, it changes this, and then maybe that does nothing. Maybe it changes this, and then the little ship at the bottom moves like 1 pixel left or something, and it realizes that okay, it survived for slightly longer by doing that. So that, you got slightly closer to those winning conditions by doing that. So just by through doing permutations of that, eventually it just optimized it, and it was absolutely smashing Space Invaders. How long did it take it to get to that point?
I think they left it overnight,
like 11 hours or something like that.
So
they came in the morning, and it's just like
they come exactly. So they went to bed, and it was rubbish. It would just like move out the way, and it would miss, and it would just be terrible and never get any scores.
Yeah.
And they came back in the morning, and it's playing it better than any human can.
Yeah, that's nice.
And the same type of the same algorithm, I think, could then be applied to like multiple other games that had like a similar kind of. The game was different, but the inputs and outputs, or the way it was constructed was similar, so they could apply it to these multiple things.
Yeah.
Which is, I mean, it was like discovering new ways to play these games that hadn't been like found out by human, experts in playing these old school video games. New ways to like bounce, in that game where
the ricochet game thing, whatever it's called, where you like bounce the little like.
You bounce a ball off and it smashes blocks at the top.
Yeah.
And it would like find certain ways to do like minimal inputs as well.
Yeah.
It found like the most efficient way to do it.
Yes, it did.
So it minimal inputs, so it would just like let it bounce and then just do all this crazy stuff that people didn't expect it to be able
and
to
that a human could possibly not even do, because it requires like a level of precision that only if you have like the raw stream of like data from the game coming in that you'd be able to actually do.
Yeah.
So that was crazy.
Yeah, it was crazy.
Was it the Go thing theirs as well?
Yeah. So that was more recent.
That's pretty recent actually. It was a couple of months ago.
Yeah.
Right?
So you probably have heard that like AIs have been able to beat people at like chess or whatever. I mean, when did the chess thing happen?
80s maybe, or
80s,
90s.
Yeah.
I'm not sure. That was actually thought of as being like a criteria of being human level intelligence at that point. Before that point, it was like that kind of level of like planning and logical thinking and stuff was a domain of humans. I'm talking about decades ago. Yeah.
I didn't know that.
And then obviously like they just built a computer which just smashes everyone at chess and just calculates all the optimal moves like every time and will beat a human every time.
There's a video of that, like one of the, I think possibly the #1 chess player in the world, like just going getting really angry where the computer's just beating him, he just walks off. And this thing's just there like beep 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 beep.
Loving chess, but yeah, Go's a whole other kettle of fish. Go's like a really complex Chinese game, isn't it?
Yeah, board game.
Yeah, board game, Chinese board game, which is like far more complex.
It sort of looks a bit like checkers, sort of. It's like black
and
white.
Yeah, like Othello. Have you ever played Othello?
I've never heard of it.
Really? It's again, it's like a board game. Like you have like black and white tiles, and you turn them over if they're if you like flank. It's really, I think it's basically a really simple version of Go. Go is like insanely complex.
Maybe I have. Anyway, yeah. Go on.
Has all these like permutations, like billions, right? Billions upon billions.
I think it might be trillions.
Trillions of permutations.
Yes,
of, like,
it's
possible...
like 10 to the some number. It's ridiculous.
Yeah, and up until now, no AI has ever been able to beat like the top human players at Go.
No, because there's just too many variables to build.
Yes.
Until now.
Yeah, until now. Thanks to DeepMind.
Yeah, so they built using these like self-learning algorithms. This
same kind of stuff.
Same thing as the video games, just playing itself at this thing over and over again, and it learned how to play Go to a level, which is able to beat some top Go players. I think it was 5-0. Like won 5 games.
Nice.
Apparently, the guy against one of the like top Go players, or like a professional Go player.
Yeah.
And he said that the way it was doing it's kind of the way it was playing was like he felt like he was playing a human.
Was it
because of the way it was kind of like using like predicting things and kind of
right.
Just
like
the way it was
dummy
reacting.
moves and kind of like setting things up. And yeah, man,
which is crazy.
That's crazy.
And they're set up to play on like for between like the 9th of March this month.
Yeah.
And the like 12th of March or something like that. So like 3 or 4 days in some place. Might be in Hong Kong or something like that. They're going to have the I think it's called AlphaGo, the program. This like algorithm they've written to do it is going to be playing the top Go player in the world. Over like a cloud server.
Oh really?
Yeah. And yeah, they're going to see if they can beat the top Go player in the world with this self-learning thing. I imagine it's probably going to win.
Yeah. I want to watch that. Well, actually, I have no idea.
I think they might stream it.
Yeah.
But it's over like 3 days.
Yeah.
But,
right.
But I want to watch the first game just because I mean I don't know how long a game of Go takes. It might take hours.
I just want to see this guy like the Go champion just being like just not believing. Like what the hell's going on with this thing? Yeah.
But that's So it's again it's this self-learning, very very new kind of type of system they're using. I mean whatever it does, is far more advanced. They keep getting like publications in Nature and things. This is a big deal. This DeepMind.
Yes, they are. I mean they've been heavily invested in by like some big names.
Well,
Google bought them. But other people like Elon Musk has donated loads of money to them and stuff like that.
They want to keep an eye on AI development.
Yeah, which is fair enough.
Yeah, I mean Jesus.
Yeah.
And Christ knows what they were going to end up. Well, I mean, if we think about like how you might go from ANI to AGI, kind of like, I mean, there's a possibility that you might not even realise that happens.
Yeah,
and that's why people are scared.
That's the thing. We've been talking all the way through this about people sort of pursuing AGI as like a goal. Like, right, let's design something that's generally intelligent. But it's actually quite possible with some of these really really complex. Narrow intelligence systems that already exist, that they become sort of more interdependent on each other, and this all just kind of happens like naturally as things get more advanced, and we kind of rely on them a bit more, and we program in more capabilities into them and more learning capabilities. That you get something that might be thought of as an AGI emerging without us aiming for it, like without us even possibly even realizing that it's happening. I
mean, maybe. I mean, it's possible, right? I mean. Something like a self-learning algorithm that has to learn how to do something. I don't know. Would you not realise though? Maybe.
I mean, maybe not realising is the wrong way of putting it. But
you don't quite you realise that it's able to do some sort of like self-improvement kind of systems, but you don't realise that it's becoming. It's going through like a runaway phase. You don't realise until it's too late and it's gone through it.
Yeah, like so the Google image search. Thing, which is basically just, I think actually not the image search where you upload an image and it just like looks for the similar image, because that's obviously quite a narrow intelligence thing. But this thing that they've been coding in, which is the point of it, I think the express point of it is that because it's so difficult for a machine to recognize an object.
Yes.
Basically, if you give a machine like a picture of like a glass or something, it will just query that against like a huge database of like similar images until it finds like a close enough match or an averaged match, and then those images are all assigned like a name, like glass, and it's like that must be a glass, just process of matching.
Sure.
But our brains don't do that. Our brains, like as we were talking about the other week with that idea of like the apple picture of an apple versus an actual apple, like the conscious experience of seeing an apple, you're integrating all these different parts of like your knowledge of what the actual meaning of an apple is.
Yes.
Like more than just like the raw like image data coming into your eyes. There's more to it than that. So the Google approach, which on a very basic sense is trying to get at that, is like trying to teach through self-learning, trying to teach like this system how to like extract like at least a word out of an image. So like you give it an image and it's like it recognizes that as like a glass or an arm or a tree or whatever in like all these images in all these different situations.
Well, they had like one where they're like asking it to recognize like a dumbbell, and like it ends up having these different images of dumbbells, but they always have an arm attached to them.
No, well that's the thing. So the actual thing was designed specifically to you give it an image and it extracts a word from the image.
Yes.
Right. Whereas what's been applied to the other way around is you feed it a word, and then it generates an image.
Yeah, in this particular.
And those images are nuts if you look them up. Like the dumbbell ones is this weird sort of like distorted kind of like it doesn't look quite right.
No.
But yeah, it's been
like
put in like
shadowed kind of by lots of edges of other dumbbells and kind of like this weird kind of kaleidoscopic kind of image generated from all these different like neural networks which are feeding in like different answers to different levels. So it goes through like 10 or 30 like different like levels of neural networks, right? Yeah. In which they like confirm or kind of basically like rudimentary like integrated information, asking like, different things about different types of like why this might be something or why not. And it gets to a point where it generates kind of these when you feed in these words, it will generate like this kaleidoscopic image of what it thinks a dog looks like or dumbbells or and they look like someone on acid has tried to paint something.
It's crazy. Like just look it up. I mean you can Google something like Google image dreams or something like that and you'll find it, and it's just like some of these pictures are just absolutely like you can't quite make you look at them and you see exactly what it's meant to be, but you also see like 10 or 30 other things in there just kind of weirdly like weird layered on top of each other. Yeah. It's really strange.
And like a car with like a sort of dog head and all these like really bizarre
like a tree
things.
A tree that's like got the heads of dogs like kind of coming out of it and it's freaking strange
it's
stuff.
Really odd.
But that's essentially
cool.
What it's doing is try in a very rudimentary way is it's trying to extract meaning from a word. So you give it a word and that's its interpretation. It's like mental image of that word. So when in the same way that you can say the word like apple to somebody and they know what an apple is, this is like they know what an apple looks like. This is that system's sort of version of that in a very, very basic sense. And to do that, it's obviously drawing on like the internet, images on the internet. Huge, like an almost infinite database to draw on of experience of knowledge of experience of what like dumbbells look like or trees look like or whatever. So I mean the internet itself, just the fact that you can put something like a system like that, an algorithm like that, give it the internet to work with, and it can come back with things like that. The internet's like it's just ripe. It's like a breeding ground for these kind of artificial intelligences. Yeah.
So if you did have a runaway process that you didn't fully understand what it was doing. You say you integrated like a new module into a very complicated bunch of different ANI like neural network systems, and you put a new module in, and that was like the development of the hippocampus or whatever like in humans that makes us so much different. It's kind of that like you might integrate the module. It's working much better than before, but you kind of like go to bed, leave it running, and you come back in the morning and you don't really have a clue what's happened because it's like uploaded itself to the internet and just gone mental. And so you don't. There's a possibility. There's a fear that we could inadvertently like produce something that begins to be able to do recursive self-improvement, and we have like no control over it.
Exactly. Without specifically aiming for it. So not coming out of one of these groups who are actively pursuing how to do it in like the safest, like best way possible.
Yeah, but rather just trying to complete a task really well and like a simple task.
Just trying to complete a task really well, and we've got a slightly new way of doing it. It's very complex, and we just kind of plug them two things together, and before you know it, it's done things you never would have predicted it would. Yeah,
because some of these integrated systems, like the Google image search, have already like extrapolated themselves away a little bit from like what the basic like people there's not really like a single person who understands like the thing from the very top to the very bottom. I mean it's like that with like operating systems have got just like so much legacy code that no one person knows every detail of all of it. So potentially you could like inadvertently plug these things in, and which creates like which is like the one of the key things to like integrating information in a particular way if we're using that for it to run away with itself. I feel like. I think, yeah. I mean, it seems possible, but I feel like it would more likely come out of someone very deliberately, like going in for that. I feel like it would just be it's too kind of serendipitous, too kind of lucky to.
Yeah, it's possibly,
but
the chances of it happening just purely by chance, by putting two things together or some sets of things together that just happen to work like that. It's probably quite low.
But you might. The thing is, I suppose you might already have like loads of self-learning kind of things already in the system. That you've just plugged something in that makes it just that much better at self-learning, that it begins to understand its position in the system.
Yeah.
And allows it to there is probably a threshold point in which this you give it like the ability for instead of neural networks, they can like strengthen connections suddenly if you put this like new module in, and it suddenly begins to like behave more like a brain and kind of just starts going a bit mad and you don't really understand what's happening with it until it's a few weeks down the line and it's kind of just started doing things that like it shouldn't be, and you just create there's a possibility that you could have that runaway effect without really understanding what you've done and when you've done it.
Sure. And like the internet itself is like a massive network. It's almost like
a human nervous system in a way.
It is, sort of is. It's just not behaving in the way that like a highly integrated.
It's not integrated. No.
Intelligent system should be or would be. But the kind of the physical like framework is almost there. Like you can imagine actually just like the internet itself being like what it eventually emerges from, possibly.
Just climbs out of a computer.
I don't mean literally like climbing out of it, but that's the kind of like rudimentary structure that kind of forms the basis of
or something like a smart city.
Yeah. Okay. Yeah. That's another good.
Like where it has to understand like the spatial position of everything.
The thing is, a smart city will very, very likely be connected to the internet.
Yeah, exactly.
So, but it was a concentrated.
It would have to have like a very high, again, like these very high levels of self-learning anyway for it to even start getting close to that.
I mean, a smart cities. If you have like autonomous cars throughout the city and they're all communicating with each other and they're all like learning about their environment, and you've got like various other like systems happening, like sewage and electricity and all these different things happening all over the city.
They aren't going to just like randomly clump together and form like a super bot. But like if you started integrating a system which is very highly capable, like that is like compartmentalized and has like a central kind of core system, an AI network, a neural network of things, then potentially those inputs could result in it seeing like certain processes that realize that it needs to kind of like go back and improve something within it to do something. I don't know, but
yeah, sure.
There's all sorts of potential kind of scenarios you can imagine. In which you could get this thing to emerge, and even if you knew what you were doing, and we'll talk about this more next week when we're going to do more about like what the actual future implications of this, rather than kind of like the road to it.
So what's going to happen to us? Like, what does it mean? Even though the singularity is one of those things that you can't predict, or even potentially imagine what's going to happen after.
Even if you are planning, like very specifically. That you want to create this thing. Yeah. As soon as you create it, you might have like no control over it whatsoever. So it will just go. So people often say like, "Why is everyone so scared of AI? Can't you just unplug the computer?" And if you don't fully understand that it's got to a point where it's like phi level is enough that it can decide to upload itself to the internet in order to like even if you give it like a really basic goal like making bricks or something.
Yeah,
and it's just like wants to get better at making bricks, and you just told it to get, and it realizes that like to get better at making bricks, it has to like leave the computer system it's on to like access more computing power in order to do this better. Network itself, and you just end up losing this thing to the internet or losing this thing to something. And I mean, if it became so intelligent that it could like manipulate humans, that's like further down the superintelligence road. Once it's gone off that, though, it reaches that level very quickly. I mean, think how many people are like tricked by emails telling them that like their financial account is, in Nigeria. There's a Nigerian space guy who like needs some help. That was a recent scam that went around. He's stuck in space and needs to get some money out of your bank account. Those kinds of things. It could manipulate humans if it's got access to the whole internet and it understood like human interaction from learning various things about human interaction from all the different social media things, could very easily start like manipulating humans to do things for it wanted to, and
yes,
that's further down the road, and we'll talk about that more next week.
Yeah,
but potentially you have very little control over something that's a lot smarter than you, and
yes,
it's getting
that's exactly
smarter.
That's exactly it. It's getting smarter all the time, and if it has uploaded itself to the internet. I mean, you may even need something on the scale of the internet to even design a system like this anyway. So just like unplugging a computer might be like just practically impossible anyway, just because of the criteria, the kind of physical constraints of building something that's this complex.
Yeah.
But say it was in a small box and managed to upload itself to the internet. Like by the time that you might say, okay, let's just like literally destroy the internet, remove like all computing power from the entire world. Just EMP the globe. Let's go back to the dark ages, get rid of it. But by the time you've thought of that, it's already thought that you're going to think of that and taken steps to like stop you doing it.
Yeah, potentially, because if it's an intelligence explosion, if it's exponentially getting smarter.
Yeah.
I mean, there's ridiculous examples of
and we will go into this
3 hours later, that it's basically like a super intelligent thing that's more intelligent and knows more about the world than the combined like knowledge of every human ever.
That's the extreme example.
That's
like
the extreme.
3 hours. Like there we go.
Yeah.
Turn it on.
Double.
It's like solved all the problems of the universe and like,
yeah.
Like predicted all of our moves we're going to make to try and switch it off or whatever.
Yeah.
Yeah.
So it's something that it's very difficult because it does sound like sci-fi.
Yeah, it does,
and it is at the moment.
Yes, it is.
But there's reasons to suspect that it's not an impossibility, and because the consequences are potentially so great, and the impact's so wide-reaching, and I mean you can forget almost everything, every other problem humans have, or every other challenge that we face, energy, climate change, meteor impacts, every existential risk potentially dwarfs in comparison to getting AI right.
Yeah.
Because it can either sort them all out or really...
That's exactly right, yeah. And almost every invention and every development that we've ever made is just completely steamrolled by this thing. Like, it potentially...
It's the last invention we make.
Yeah, exactly. It's the last invention we make. And in a way, it's like... It kind of makes all the rest of the stuff that we've done seem almost pointless. I mean, development happens incrementally, and that we wouldn't have got to the point of making this thing without those developments.
No.
But it would be able to go back and do everything that we've done much more efficiently and in a much better way.
Much faster. And getting faster and faster and faster and faster all the time.
Yeah.
So it's something, and again, like we said, it sounds like sci-fi because it's an exponential curve. You only realise you're close to it when you get really close to it.
Yeah. And it's coming real fast.
And so that's why the predictions are so early, seemingly, for the singularity, is that they're like 2050, because if things keep going the way, and they're starting to seem like with like theories of how understanding like how minds work, how getting self-learning machines are so suddenly just so much more advanced than they were before.
Yeah.
And so much more capable with the internet and search engine and everything. They've never gone through this like level of interest and people working on them and stuff, because they're suddenly becoming like commodities that are really valuable to help run the internet, run like the economy, run everything.
Yeah.
And it's just everything's starting to. Every time I like read more about this, I just start thinking that it's getting closer and closer.
Yeah,
that actually these dates don't seem as mad as maybe it seems on the outside, which is interesting.
Yeah, it's awesome. I mean, it's potentially terrifying, but as I said earlier, like it gives me a feeling like it's just this thought of like the singularity. So like the world essentially changing. It's the end of the world in a way.
It's the end of what we know as the world.
It's the end of this world. If it
happens in the way that people are talking about.
Yeah.
It's essentially the end of modern civilization as we know it.
Yeah.
It is the apocalypse in either a good or bad way.
Yeah. And we will talk about how it could possibly be one of those two things.
Yeah, and how we might avoid them and
next
how
week.
we might try and get it to be good, bad, etc. All these types of stuff next week. But it's a really important thing that everyone should be thinking about.
Yeah.
Because even if it doesn't come, it doesn't actually work out the way we think. Sure, that's fine. But AI is still going to be hugely useful in terms of like technological breakthroughs in every field.
Yeah, and
even if you can't get
more
like
advanced.
a recursively self-improving system, then that still doesn't matter because it's still a hugely important thing.
Yeah.
But the fact that there's a chance that you could, and most of the experts in the field think you definitely can.
Definitely can and definitely will.
And definitely will, and that it's actually quite soon.
Yeah.
Means that because it's the biggest biggest thing we've got to get right or wrong.
Yeah.
It's the most important thing potentially that we'll ever do.
Yeah.
That everyone should be at least thinking and talking about a little bit more. I mean, yeah.
Compared to things like climate change, which actually,
which is important, obviously,
massively important. But in terms of its potential impact on the future of civilization, is nothing.
No.
In potential compared to this.
AI, no.
And so much is dedicated towards climate change research,
Yeah.
climate change mitigation, and all this stuff.
Yeah.
But very, very little is actually dedicated to AI research.
Well, that's changing.
It's changing. It's changing quickly, but in comparison, it's a huge.
Yeah,
huge
the general kind of like if you talk to anyone, like everyone knows about climate change.
Yeah.
Not many people know about like the risks and kind of dangers and the potential changes that AI can bring.
Yeah.
So yeah, chat to people about it because it's fun.
Yeah, it's
and
really
it's
cool.
Potentially extremely important.
So that sort of wraps up this week's episode.
That's the end of AI.
Plenty more where that
plenty,
came from.
Plenty more AI next week.
So now it's time for this week's Nutters of the Week.
Yeah.
Announcing that like it's an actual thing.
Yeah, everyone's been talking about it.
Yeah. Hashtag NOTW.
Oh, nice.
Yeah. I thought that one through.
What is your Nutters of the Week?
So, well, I mean, it's a bit of a tangent, a bit of a sort of a change of attack from the last few weeks of like conspiracy theories and stuff. And you're very familiar with this because we sort of discovered it recently. But I wanted to talk about this rapper Viper.
Oh, it's so awesome.
I mean, he's
right. Okay,
it's
so
a revelation.
He's not. I don't know. I don't think he's not nuts.
It's probably unfair to call him a nutter.
Yeah, he's not in a like a positive. I mean that in a nice way. Because he's fucking awesome.
Yeah,
he's awesome. The thing that's nuts about him is that he produces. He's a rapper. Okay, he's like an internet like outside kind of artist rapper.
Yeah,
not signed. I think he's signed to a label or anything like that. He just produces music.
Like a bedroom producer. Yeah.
And he produces roughly an album a day.
That's insane.
And they are like the weirdest, like trippy albums.
It's real strange stuff. It's sort of almost like those Google image things we were talking about before. It's like the musical equivalent of that.
That's so true.
Like weird, like distorted. Like it's all kind of like washy, like. Yeah, I mean his song titles and album. I mean, it's just the way I found out about it.
Yo, cowards don't even smoke crack is his biggest hit.
Yeah, that's his big hit.
Yo, cowards.
As in like that's like an argument to use. Like, oh, what are you saying? Like, you don't even smoke crack. It's like, yeah.
And the song's like so dreamy and trippy,
weird,
and like
weird song.
Like the vocals sound like they're stretched out.
Vocals are really deep and like.
You should definitely check it out.
It's a strange experience listening to this music.
Yeah, actually, and that song, to be honest, is it's not normal. But if you listen through his albums,
there's weirder stuff.
And you go down Spotify and you will keep scrolling and the scrolling. And the list like hundreds of albums long, and it's still like it says 20. It's still the 2015 albums.
Yeah, he reached like 350 albums in 2015.
Yeah, 2014.
Ridiculous.
Yeah, it's crazy. And I mean, when you listen to some, because there's so many albums, you listen through them, and it's like entering like a weird kind of world of.
It's like
I think it's cloud rap or something. Is that the genre?
Yeah, I think people give it some names, whatever. It fits within some genres or whatever, but like it's strange. And this guy is churning them out. Imagine like being in his head. Like he's got all this like weird like synthy kind of. Is it dark? There's dark aspects to it.
Yeah, it's a bit dark.
There's something to it that feels quite a little bit sinister, a little bit kind of.
It's not like depressing dark. It's just there's something about it that is a bit off.
Yeah, a bit off. That's a good way of putting it. But also hilarious
and brilliant.
Like absolutely.
And some of the songs, to be fair, are actually quite good.
Quite good. Yeah.
I can't believe that he's able to produce most of these albums have like 15 songs on them.
Yeah, 15 songs.
He's producing one of those a day on average.
Yeah. And sometimes possibly two, like according to an interview, right?
Yeah.
30 songs a day.
Is it
written
Like
recorded,
think how much
produced.
effort goes into writing a song normally. Like recording the beats, like working out the beats, getting all the different layers to it, the vocal, writing the lyrics, writing the song titles, everything like that. And he's banging them out every day.
Yeah.
And they're like, some of them are pretty long songs, and they have proper beats and
like the structures. It's not just like a loop for like 2 minutes that he just sort of says some words. I mean, some of them are like that.
Some of them are.
But then there's other ones that are like proper songs with like structures, and he's obviously written a song.
Yeah.
Like his mind's just going with this music just constantly every day.
Bananas.
He must just get out of bed in the morning and just be like, right, sit down. Let's spend all day just making music. At the end of the day, upload it. Right, another album done.
Yeah. It's great.
It's great. Yeah.
He's great. He's definitely crazy, but in like a good way.
In a great way. In a very, very great way.
So go check out the rapper Viper.
Y'all cowards don't even smoke crack. His being his number one hit.
Oh, brilliant. Yeah, that's a great Nutters of the Week. Even though it's not really what we normally do for Nutters of the Week.
Yeah.
But it's worth mentioning because it's absolutely awesome.
Yeah, it's brilliant.
Right.
Thank
you very much for listening to this week's. And we'll be back next week with another big fat chunk of AI conversations.
Yeah, talking about... Well, we've already told you what we're talking about, so that's fine.
Yeah. More stuff in the future.
Outcomes of the singularity.
Yeah, yeah. And some of the kind of like sort of should we do it, should we not do it kind of
maybe
issues.
more the ethical choices involved and stuff like that.
Yeah, yeah. There's plenty more to talk about with AI. So.
Yeah.
And we'll keep going back to it, and like as we have done in loads of other topics.
Yeah.
Because it's related to almost everything.
Yeah, yeah.
Everything in the future.
Cool.
Right. Okay.
That's it. See you later.
See you later, guys.